Um, Welcome to the third module of this course that speaks to communicating on a local network. Here is the agenda for this section of the presentation. Now, the first one is the principles of communication. So, primarily, there are three basic elements for communications to be established. The first one is the source, which is the sender of the information, the destination where the information is going to, and the medium of transmission by which we the message is passed from the source to the destination. We also have a set of rules that governs how communications are established, and those are protocols. Protocol is important to ensure that communications follows a set of guidelines across devices, across vendors, across organizations. They maintain unique standard. This is a very important aspect of communication. Now, who are those that makes these rules? They are organizations, standard organizations across the world that are saddled with the responsibilities of maintaining these rules that governs communication over the internet. We have a couple of them. From amongst them is the IEEE, we have the TIA, the ITU, and the host of others. Then now, these different protocols, they are layered in a stacked up in a layout model, kind of. So we have different types of models. The first one is the TCP/IP model, and we also have, which is a protocol model. Then we also have a reference model, which is the OSI model. The TCP/IP model, as you can see from this table here, has four different layers, while the OSI model has seven layers. Now, going into more details, the OSI model has two groups. We have those that are categorized as the lower layer, while some are categorized or grouped as the upper layer. So from those from the lower layer, we have the physical layer, which is in charge of the physical medium. That's where your copper cable or optic fiber cable, the wireless transmitters, your NICs, all these devices comes under the physical layer. Then we also have the data link layer. This is where you have your network interface drivers, where the network switching happens, WAN connectivities, and other activities just above the physical layer. Then on the network layer is where IP addressing and routing comes in, while the transport layer is the streaming mechanism. Firewall comes in. That is where you start talking about TCP, UDP, more like how is this packets transmitted over the network. Then we have the upper layers, which are the session, presentation, and application. The upper layer speaks to how the information or the packets are presented to the end user. And in this, we have network aware application, the web browsers, the file transfer, naming resolutions, and a host of other activities that happens on the upper layer. So as we progress, we would be referencing this in the subsequent sections. Now, doing a comparison of these two models, as you can see, the data link and physical layer of the OSI model is equivalent to the network access layer in the TCP/IP model. While the network layer is network, the transport layer is transport, then the three upper layers are referred to as the application layer. So both of these models are they are worthy of being familiar with, and it's a good practice to actually have like a mnemonic to memorize these layers. They are the foundations for networking, kind of. Now, the next slide is talking about Ethernet. Now, Ethernet is the de facto standard for cabling, wired connection, and this has evolved over the years from the 70s to the 80s and to where we are now. And the current standard for Ethernet communication is the IEEE 8023, which is the current standard. Then, yeah, like we mentioned earlier, this technology has evolved over years, from as far back as the 70s. Now, addressing on the internet layer makes use of what we call the physical address, which is also known as the MAC address. And this address is assigned to the network interface card by the manufacturer of this of the networking or the network interface card. Now, how does it work? It works using the process called encapsulation. Encapsulation is more like embedding information inside information, like you're encapsulating a message inside another. So that is the why the encapsulation is the reverse of this. So before a message can be sent over a network, this message has to be framed. So in a typical frame, we have the preamble, which with the size of 7 bytes, the start of frame delimiter, we have the destination MAC address, the source MAC address. The sixth here indicates the size of the size of the memory it's taking, while the type and length takes 2. Then the header and the data that you're actually transmitting takes between 46 and 1500 bits. Then we have the frame check sequence, which is to check for security of the frame. Now, the building blocks for an Ethernet network makes use of the hierarchical design. So in an hierarchical design, a MAC address is what identifies host on the network, but obviously you can't use it beyond a local network. So once you want to move beyond a local network, then you need what is called an IP address. So the benefits of an hierarchical design is that you'll be able to you in most cases you separate the network based on layers. We have typically 3 layers: the access layer, distribution layer, and the core layer. So like we mentioned earlier, this is like a diagram showing what devices are on the access layer. As you can see, we have end devices, which are more of personal computers, smartphones, tablets, VoIP phones. They are connected to a switch. Then each of these is more like a local network. We also have another local network here, another local network here. Now, combining this local network, you have a distribution layer where the local networks are connected using a router. Then to the core layer, which is more like the advanced routing, where advanced routing actually occurs. Now, like we mentioned earlier, the access layer devices are the first line of networking devices, which are more like the end devices that we use. Then we also have the Ethernet hubs and switches. Now, the primary difference between a hub and a switch is a hub is can be described as not too intelligent, hence it creates excessive collision domains, while a switch is a more intelligent device, accept and decodes frame with MAC address. It has what is called the MAC address table that maps the MAC address of as like a table. The table contains the list of all active ports and the corresponding MAC addresses of the different host devices that are connected to them. Now, this is how a typical MAC address table looks like. You have a port and the MAC address of that port, another port, the MAC address of the device that is attached to that port, like that. Such that when a host, for example, H1 is trying to send a message to H8, the system does like a broadcast message to request for the MAC address of the destination MAC address, and the protocol just checks through the MAC address table to find the destination MAC address, sends that back to the source device, and communication is established thereafter. Now, what of if in a situation whereby the content of like the MAC address of a particular host is not registered on the MAC address table? That is where broadcast comes in. So a broadcast message is simultaneously sent by all hosts on the network, and the Broadcast MAC address looks like it's in hexadecimal notation. You have F all through. Now we mentioned broadcast domain earlier. So a broadcast domain is just a simple network. Now going forward, communicating at access layer. To send message, a host will need an IP address and the MAC address of communication host. So IP address, we are going to talk about that in more details in the upcoming section. Now, the sending host can use a protocol known as the address resolution protocol to discover the MAC address of any host. So that means we also have what is called like a table that keeps track of IP addresses and the corresponding MAC address of the host that has that IP address assigned. So the protocol that is in charge of discovery of IPv4 addresses is the IP ARP, while that of IPv6 is known as the neighbor discovery. Now, how does ARP works? Now, this PC is attempting to ping this IP address. So the first thing it does is that send data is the MAC address in the ARP cache. If yes, it sends the ping. But in a situation whereby the MAC address is not known, what it does is it sends an ARP request to this with the destination MAC address of a broadcast, more like send a broadcast message ARP request to all the hosts that are on the network. Then the particular host that owns this IP address of 10.1.1.1 replies with the corresponding MAC address. Then the MAC address is thereafter stored in the ARP cache. So subsequent communications does not have to do a broadcast again. Then dividing networks, the local network, you divide local network to actually reduce the collision domain as much as possible, while each of these local networks are connected together using routers, and that is where routing comes in place. So routers and routing are required to actually reach remote networks. Routing itself is the process of identifying how best you can send data from a source network to a destination network. So when you're routing across networks, you need to select a path. Then there's also a routing table similar to the ARP table that describes the network and the outgoing ports. Like following this illustration, we have a router here. Then the port here is named Fast Ethernet 00, while the port here is named Fast Ethernet 01. So on the routing table, it documents the IP address of the network, like the network address that is attached to this port, while on this other end, it documents the network address that is attached here, such that when there's a need to route to this network, just go straight to the routing table, picks the port that links to the destination network. And local area network is just a group of interconnected local computer. Once you connect two, three, four, five pieces together, you have a local network kind of. So it's the smallest form of network that we can have. And yeah, placing all lost in one network segment. This is an illustration. So this is a local network, this is another local network. Then when you want to connect them together, you make use of a router. So that enables communication between this local network and this local network. So this second one now reduces broadcast domain because it's separated. But here, all these computers are considered to be on a single local network as against separating them by with a router, which reduces the collision and increases efficiency of the communication over the network. So I think this brings us to the end of this section. In the next section, we'll continue with the next topic. Thank you.